Okay, we're on.
All right, so it looks like a curveball, but it's not quite. It's similar to the previous example, except that I'm not giving you a point. So we need a point on the terminal sides, right, of that angle. So the first thing we need to do is draw a picture and see what's going on. So this one I'm telling you here, the terminal side is defined by two things, an equation and an equality. What is that equation, 3x minus 2y equals 0? It's a line, right, that goes through the origin. Right? So first thing we do is we're going to draw it. So here, if we were to draw this, this is if we solve a line in the form y equals mx plus b. So if you rewrite in the form y equals mx plus b, you get what?
Negative 2y equals negative 3x.
Or in other words, y equals 3/2 x, right? So that's going to be a line that goes through the origin, which we knew because, again, by convention, the vertex of any angle is located at the origin, so that will go through the origin. And the slope is 3/2, means rise over run, right? So I can draw that. And not only it's going to be on that line, but also we want on the x to be negative. So that means we're going to be in, looking at the terminal side is going to be in the third quadrant. Because it's going to be the line here, positive slope, so it's going to be looking like this. But I want x to be negative, so I'm going to go in that half of the plane here. So what we do is go through the origin. The slope is 3/2, so remember it's rise over run. You go up 3 over 2, up 3 over 2. So up 3 over 2, up 3 over 2, so that would be like something like this. But I want to look at just the negative x, so I'm going to go over here.
Why is that?
That's part of it. X is less than or equals to 0.
Oh, I didn't see that.
So this is my terminal side. So this is my angle theta, right? So this is y equals 3/2 x, where x is less than or equals to 0. So what we need here, in order to find the trigonometric functions, cosecant theta and secant theta, we need to find a point on the terminal side. So what would be a point on that terminal
Negative
side?
3, negative 2.
Repeat again?
Negative 3, negative 2. Negative 2, negative 3.
That's better, yes. The point negative 2 here, P, which is negative 2, negative 3, right? You could choose any points you want. And how do you find a point on the line or on a graph? You choose any random x's. Here x has to be negative, so I could use negative 1, negative 2, negative 3, negative 4. And then you find its corresponding y. But because we are dealing with a fraction, it's 3/2. You might as well take x being multiple of 2's. That's why I will choose negative 2. So in any case, you use the point P. And again, you could have chosen the point negative 4, negative 6. It's up to you guys. But we're using the point P, which is negative 2, negative 3, which is on the terminal side. And now we go, that's the same problem as before. We find its distance. So what is distance here? So R here, which is so P here, on the terminal side will be the point negative 2, negative 3. Its distance from the origin, R, is going to be the square root of negative 2 squared plus negative 3 squared. That's square root of 4 plus 9. That's square root of 13. And again, I have now everything I need to answer the question. I have a point on the terminal side. I know its distance from the origin. So I just, as long as I have this memorized, well, remember, again, you can, if you view it as in the right triangle and a SOHCAHTOA, you can also figure that out. We are in good shape. So cosecant, the value of the cosecant at that angle, which remember cosecant is defined as the reciprocal function of sine. It's r over y. Here r was 13, square root of 13, sorry, and y was negative 3. So it's negative square root of 13 over 3. And then secant, which is the reciprocal function of cosine, is defined as r over x. And so it's going to be square root of 13 over negative 2, or negative square root of 13 over 2. So the two values are negative square root of 13 over 3 and square root of negative the square root of 13 over 2.